Okay, so we'll start with the discussion with two-way Anova and shout out kay Martin na nandito ngayon. Yung ibang hindi nakapunta, so I'll be recording this session for you guys. Okay, so we ended our last lecture with randomized complete block design, no? And I've mentioned na yung randomized complete block design is similar to your two-way ANOVA. In fact, the method of solving it is actually the same, pero ang only difference is hindi natin tinitreat as isang factor um, yung yung blocks natin, no? Okay? So we'll try an example ngayon. Nasaan yung We'll try an example of a two-way ANOVA, no? And nandito pala siya. Oops, sorry. Saan ba yun? Saglit lang, Martin. Okay. Dito pala. Okay, so magta-try tayo ng mga examples with two and other two-way ANOVA, no? So usually, pagka nagto-two-way ANOVA tayo, magiging mas complicated yung ano ba yun? Nasa screen ko. Ano? Usually, mas complicated siya kasi lalo na pagka, kunwari, I've shown an example na, ano, no? Yung complete block design wherein ang ginawa natin is meron lang tayong one replicate tapos each kumbaga replicate if we could think of it as we thought of the replicates as the blocks, no, pero it was each replicate was arranged per block. Okay, pero dito sa two-way ANOVA, we are considering the other the quote unquote blocks as another factor, no? So meaning that we will have two factors, and and for each treatment combination of the different factors, pwede kasi magkaroon tayo ng replicates, no? Pero there are cases also na hindi tayo magre-replication. Pero for cases na magre-replication tayo, the table will look a little bit parang wonky, no, kasi medyo mahirap i-layout yung table to. So let's do this example, no. So meron daw experiment to be conducted and kailangan i-determine if yung missile system missile system or the propellant type has a significant effect on the response variable, which in this case the response variable is the burning rate. Okay, so meron tayong ang magiging factor natin dito is itong missile system, which we've labeled as factor A. Tapos we have your propellant type, which we've labeled as factor B. Okay, then from this table we can see na meron tayong three types of missile system. So that's three levels for factor A. Tapos propellant type, we have four levels naman. Okay, and each um, of the treatment combination has two replications. No? So for example, level 1 factor A and level 1 factor B has two replications, which is etong two observations na to, which is yung 34 and 32.7. Okay? So it matters, no, kung paano natin siya i-layout kasi doon sa Excel, if we do the fast method the Excel, no, nagma-matter kung i-group ba natin by rows. Kunwari ito, each factor is grouped by rows, no? If you can see it na parang yung each replication is parang arranged in a row, no? So for example, ito first replication, second replication. So pwede kasi we can alternatively show it as ano no. For example, yung first replication is in this, we can group it by column naman. So first replication is this column, second replication is this column. Okay? So that could also work in Excel, pero kailangan may certain tayong mga boxes na kailangan i-tick para makuha yung desired results, no? So it matters kung paano natin ni-layout tong um, yung yung table natin, no, yung given table. Okay? So yung magiging hypothesis natin is that we have three null hypotheses, no? So meron tayong number one, yung first null hypothesis natin, which we can label as uh, H naught prime. So there is no difference in the mean propellant burning rates when different missile systems are used. So that is, kumbaga, yung factor A has no significant difference, has no significant effect. Yung H naught double prime is there is no difference in the mean propellant burning rates of the four propellant types. So parang we are saying na factor B, which is propellant type, has no significant effect on the mean propellant burning rate. Tapos yung third natin na H naught is yung we call this as H naught triple prime, na there is no interaction between the different missile systems and different propellant types. Okay? So dito na ano no, so doon sa Anova table I've laid out before na meron tayong mga source, parang diba, source natin is treatments, error, tapos total. Pagka nagkaroon tayo ng multiple factors na, we will also have to consider the interactions between them. So later I'll show it to you, pero parang just a preview, ang magiging source na natin ngayon is source is factor A, factor B, interaction AB, tapos error and total. Tapos you can imagine, no, if you have three factors naman, kunwari higher factor ANOVA, magiging mas complicated yun, no? So actually, hindi lang two-way interaction ang meron. Meron ka pang three-way interaction. So it will be something like main factors, main effects muna na A, B, and C. Tapos meron kang two-way interaction, which is two-way interaction mo is AB, AC, and BC. So just a the number of ways you can arrange two factors. Parang three combination two siya, no? Parang ganun. Tapos yung last is yung three-way interaction, which is ABC. Okay, so later ipapakita ko to pag nag 2 to the k fractional 2 to the k factorial design tayo. Pero stick muna tayo dito. So um, we have essentially three null hypotheses, no? So meron din tayong three alternative hypotheses that will negate the null hypothesis. Pero in this part of the lecture or this part of the course, no, hindi na as necessary na i-state yung mga different hypotheses natin, kasi doon sa ANOVA table, kaya naman natin na mag-derive na ng conclusions based on the ANOVA table alone, no? Kasi once na na-list down na natin lahat ng mga sources natin, we can make conclusions for each of those sources. Okay? So again, ito yung ano natin. So I'll be opening my Excel now. Let's copy natin yung data natin. Let's copy ko lang itong data now. Sana okay. Good. Hindi naman siya. Okay. So, ano ka lang. Merge. Shift lang tayo sa Excel natin. Nakikita naman, Martin, no?
Yes, sir.
Okay, thank you. May isang pumasok. Morning, Russell. Okay, so nandito tayo, no? So ito yung propellant types natin. Tapos kailangan natin i-solve yung may multiple, di ba ang una nating sinosolve doon sa ano is we have SS total. So we will also be computing SS total as well, no? So SS total Tapos compute na rin natin yung correction factor. Now again, etong SS total and correction factor, they don't generally they don't change in form, no? They will always be the same na parang equation. So yung SS total natin will be just sum square ng lahat ng observations including the replicates, no? Sum square ng lahat tapos minus the correction factor, which is this one. Tapos yung correction factor natin will be just sum, yung grand total natin, squared, divided by yung total na total number of observations. So we have our SS total. Okay? Ito. So ito actually yung itsura ng ANOVA table natin. No? So we have the main effects, factor A and factor B. Then you have the two-factor interactions, which is in this case, this is dalawa lang factor. We have only AB, no? So we need to compute SSA, SSB, SSAB. Tapos we've computed SST already, no? Tapos we have your error. Okay? Tapos, ito yung computations for the degrees of freedom, no? So, SSA is just the number of levels of factor A minus 1, number of levels of factor B minus 1, that's SSB. Tapos, for the total is just, this is just the total number of observations minus 1, no? So, kaya siya A, B, and this is just saying na the number of rows times the number of columns times the number of replicates. Okay? Tapos, pag the SSAB naman is just multiplying the degrees of freedom of the two factors involved. No? So for example, itong SSAB, therefore, i-multiply natin yung degrees of freedom ni A times degrees of freedom ni B. And as always, itong SSE, instead of memorizing this formula, no, it's always easier na ang gawin na lang natin is i-deduct natin yung sum of all the sources or i-deduct natin yung total minus the sum of all the, I don't know, yung lahat ng other sources apart from the error. Okay? So, eto, yung SST natin, again, same calculations, no? It's just the sum square of all the individual. So, the way we read this is the sum of square of all the individual observations. Tapos minus the correction factor. Again, correction factor, grand total squared divided by total observations. Now, si SSA naman, SSA is taken as yung sum ng lahat ng observations that is under each grouping of A. So, ibig sabihin, so if we look at an example, no, if you want to take SSA, then what we have to do is, kailangan i-add natin lahat ng per column, kasi si A natin naka-arrange sa per row pala, sorry. So we have to add all of the row totals, tapos yun yung gagamitin natin na parang yun yung i-square natin na value. So for example, ito 244, 237, and 228. This comes from etong total na to per row. So for example, sa A1, ang total na to is lahat ng observations dito. Tama? So that is 244. Tapos sa A2 naman, yung sum lahat ng treatment combinations which has the factor A as the second level, which is these two rows right here. Yun yung 237.4. Tapos, so I'll show Excel na para mas malinaw siya. So ang gagawin natin is, if you want to get SSA muna. So to get SSA, equal to sa sum squared ng, and we need to do a totals dito para mas madali. Let's do totals ng ano. So we do sum nito. So you'll notice na itong two rows na to, this will be again siya yung sum ng lahat ng observations that that has a factor A as level 1. Okay? So ganun nyo siya iisipin, no? 244. So I can just drag this down. Tapos burahin ko lang itong mga nandito, no? Kasi hindi naman sila kailangan. Okay? So ito, This is the sum of these two rows. Tapos ito naman, sum of these two rows signifying si A2. And this is the sum for the uh, uh, for the two rows that is corresponding to the A3 na level. Okay? So, if I want to get the sum of squares, again, halos same lang yung formula again. No? Sum of squares siya ng values na to divided by kung ilan yung ilang observations or ilang observations ang kailangan para mabuo yung individual na sinasum of square natin. So for example, itong 244, this comes from ilang values. That's two rows dito, no? And these two rows are equal to 4 data points times 2 replications. Tama? So kaya over 8 yung magiging ano natin, yung magiging divisor niya. Okay? Tapos minus correction factor. Okay? Malinaw ba yon? So, again, similar lang natin ang formula, no? Kasi kunwari itong SST, I mentioned this earlier din, no? Parang ganun din yung ginawa natin. Sum of squares ng lahat ng observations na to. Tapos divided by, parang ang nangyari dito is, ang divisor niya is divided by 1. Kasi each individual data comes from one observation. Tama? So, kumbaga, each value na sinasquare natin comes from only one data set. So that therefore over 1 siya. Parang ganun. Pero dito, kunwari ito, sum of square ng itong 3 values na to, each value na to comes from 8 individual observations. So 244 comes from 8 individual observations from these two rows. 237 similarly comes from 8 observations and so on. So kaya siya over 8. Okay? So we have something like that. So kung SSB naman, if you want to get SSB, we are getting the sum of squares ng factor B. Therefore, factor B is arranged by columns, no? So kunwari may B1 tayo, B2, B3, and B4. Therefore, it makes sense na itong sum ng totals na to, ito yung isa sum of squares natin. Okay? So we should get something like this, no? If we do sum square, same formula, ito. Tapos, ang magiging divisor naman natin, what do you think? Ano yung magiging divisor natin? Kung 8 yung kanina dito sa column, this should be and 6. That's correct, no, Russell? So it should be 6 kasi each value here comes from 6 individual observations. So we have 6 minus, again, yung correction factor natin. Okay? So we have SSB. Now, before we proceed with the error, kailangan natin yung SSAB muna, no? SSAB. So SSAB is taken from, balik ko lang sa no, Excel. If you want to get SSAB, kailangan mo natin i-consider yung SSA and SSB, no? So we need to actually compute for kasi if you look at the SSAB calculations, equal siya sa if you look at this first term and the second term, no? This is actually also the term for SSA and the term for SSB. So try to look at it. Magiging ito siya over BN, which is also this term. And ito is this term, no? So ang kailangan natin is si SSAB kasi is yung interaction between the two factors, no? So kailangan muna natin i-solve siya using if you notice na naka-plus yung correction factor nito, no? So kaya naka-plus yung correction factor kasi parang ang nangyari is if you really think about it, parang ano siya, etong term na to minus the correction factor. So I can probably show it better na kung ano ko ba ipapakita. Sige. Papayin ko na lang to. Okay. Baka mas mapapakita ko siya dito. So, para lang kung saan nanggaling tong plus na factor na to, no? Kasi in most cases, di ba, nagma-minus correction factor tayo. Again, this is correction factor, no? So, kaya siya plus kasi if you think about it, ang SSAB kasi is yung parang sum of squares ng interaction between AB tapos less SSA, less SSB. Parang ganyan dapat siya. Okay? So, kumbaga yung sinasum of squares natin divided by yung number of observations for which saan natin kinukuha itong sum of squares minus yung SSA minus SSB. So kaya natin mina-minus kasi yung variation na to also includes the SSA and SSB factors, but we have already accounted for them, no? Itong SSA and SSB. Kaya siya ganito. So kaya siya naging plus kasi pag bin-break down natin itong SSA and SSB into their separate terms, no? So para magiging SS yung sum of squares nung A divided by whatever value dito, no? For A it's over Bn, no? Tapos minus correction factor, tapos minus SSB which is sum of squares, sum SQ, tapos AN naman para sa CF minus CF. So dito, this is just actually over N. No? So if you notice, ito magiging positive CF, ito positive CF. So actually, ang mangyayari dyan is minus sum square over Bn minus sum square over An tapos plus 2CF minus CF. So mag-cancel out yung isang CF. So kaya siya magiging plus CF. So kaya dito, parang it appears as if, sorry. Hindi ko pala na So ito class. So ito yung sinasabi ko, no? So you have again, di ba pagka nagko-compute tayo ng sum of squares or nag-compute tayo ng sum of squares ng a particular value, nagsa-sum square tayo ng certain set of data set over yung number of observations that make up that data set, tapos minus correction factor. So in much the same way, ganun din yung sa SSAB, no? Pero the difference is pagka pag in-account kasi natin yung variation ng sum of squares of the interaction, naka-account na din doon or nakapasok doon yung SSA and SSB. So kaya natin mina-minus si SSA and SSB sa parang etong variation na to. So kaya minus SSA minus SSB. So kung i-expand natin tong SSA and SSB, magiging siya, no? Sum of square nung mga values for A divided by Bn minus CF. Tapos ito minus sum squares B, magiging sum of squares ng variation nung dito sa column total, no, divided by AN minus CF. So pagka nilabas natin yung dalawang CF na to, so it's negative to. So minus and negative value that comes sa positive. So plus 2CF siya. So kaya mangyayari is plus 2CF minus CF magiging plus CF siya. So kaya siya dito, if you observe, dito it seems as if parang weird siya kasi bakit lahat naman ng natin minus CF pero bakit dito sa SSAB plus CF siya. Okay? So we can use this formula pero actually pwede nating hindi gamitin tong formula na to, no? Kasi the thing about this formula kaya siya ginawa namin ganito kasi back in the days wherein wala pa tayong wala pang parang Excel kasi the previous offerings of METI14, yung triple ME14, no, which was previously known as METI14, hindi pa kasi pwedeng gumamit ng Excel, no? So naka-manual sila, pen and paper, tapos calculator yung gamit. So kaya namin ginawa ganito kasi when you compute for SSAB, you already have this first term, no? Itong term na to. Kunwari, nag-compute kayo ng SSAB, i-compute nyo muna tong first term na to bago kayo mag-compute ng correction factor. So, para kumbaga hindi masayang yung calculation natin yun, gagamitin natin, i-recycle natin yung calculation na yun dito. Okay? Pero actually, since nag-Excel na tayo ngayon, hindi natin kailangan mag-quote-unquote recycle ng calculations. No? So, pwedeng instead of itong plus CF, ang gawin natin is, And I think this will make sense later, no? Ang gawin natin is, ang gawin ko na lang is I can do something like sum of squares. No, I need another table, no? So I need another table here, which is parang we call this as yung response table. So this is our response table, no? This is also a response table. Pero kailangan din magbuo ng isa pang response table, which is the totals, no? Okay, so burahin ko na lang to. Okay, so ang gagawin natin sa response table ng totals is that kailangan lang na meron tayong ah, total per interaction or per parang factor combination. So kunwari A1, B1, A2, B2, etc. So ang gawin natin is sum ito. Tapos i-drag lang natin 4 times. That's the sum. Then we can copy it this way, copy it this way. So ito na yung response table natin. So this is just the sum of each of the replicates, kumbaga. So if na-OC kayo, you can actually pwede nyo gawin is burahin tong no, you can delete this and shift cells up. Pwede ganyan. So tapos check nyo lang kung same pa ba siya. Pero I just like to leave it as is, no? Parang ganun. Kasi pagka sum of squares naman ako, pag may blank naman, Excel is smart enough para i-determine na blank yun and hindi niya i-count sa calculations, no? Okay? So Excel again, si Excel hindi niya kung may blank siyang nakikita, hindi niya kino-consider as zero, you know. Parang it considers it as a null value and hindi niya isasama sa calculations. Okay? So if I do sum of squares nito and each of these values comes from 2, so over 2 minus the correction factor. Pero again, etong value na to, this already includes SSA and SSB. Okay? So, kailangan natin i-minus si SSA, minus din natin si SSB. Okay? So, we should get 22.163. Okay? And pwede natin i-check, no? Tama. Same naman yung value. Okay? So, buuin natin yung Anova table natin. So, again, naalala niyo pa ba yung Anova? Ito, hindi naman nagbabago, no? So, it's always, again, source. And by now, dapat medyo, no? Memorize nyo to by heart. So, it's source, SS, DF, MS, tapos FCalc. Then we can have, kung gusto natin same na format doon sa no, sa yung automatic na yung sa data tool analysis toolpath, then we should do p-value next. Then after p-value is fcrit. Then we can have yung conclusion natin. Okay? So first source is factor A. And if you want, you can also type kung ano siya. So para alam na agad. Factor A is missile type. Factor B, this is propellant. Ano nga factor B? Propellant type. Missile system pala si factor A. Okay? Tapos AB, which is AB is the interaction. Okay? Tapos we have your error and we have your total. Okay? So what we do is equals total ito. Tama? A is this one. B is this one. Tapos yung interaction is this one. Tapos yung error natin is just this value minus the sum of the three na sources, no? Gives us 48.91. Okay? Now, I can just drag this actually, no? Kasi if you do count of all the values minus 1, yan yung degrees of freedom ng total natin. As degrees of freedom ni A is just the number of levels minus 1, which in this case is 3, no? 3 levels for missile A minus 1. That becomes 2. Propellant has 4 levels minus 1, which is 3. Tapos interaction is just if i-multiply mo yung degrees of freedom ni A and degrees of freedom ni B. So you have A times B gives you 6 no. Okay? So you have your 16 na then yung error natin is just the kung ano yung remainder no. So what I like to do is ang gagawin ko is parang ganito na total minus yung sum ng sa taas tapos i-drag ko na lang to the right kasi same lang naman sila ng formula no. So this time ito naman yung mina-minus niya yung total na 27 minus itong 2 plus 3 plus 6. Okay? So MS it's always SS over DF no. And I can also drag this down. Ganyan. So I have MS values. Tapos si Fcalc is equal to ito divided by yung error natin. No? Okay? Tapos I can also drag this down pero gusto ko na kasi 'di ba pag nag-Fcalc tayo as always ang denominator natin is si MSE no. So pwede ang gawin ko is I'll press F4 para malagyan ng dollar sign. So therefore hindi maggagalaw si MSE. So para pag din-drag down ko na ganyan always denominator ko si MSE or MS error. Okay? So if I have Fcalc, then I'll compute for P value which is just F dot this dot RT. Again, always right tail tayo no? Ng F crit na to. Ng F calculated na to. Degrees of freedom is numerator is the source. Denominator is always the error. No? Okay? And pwede kong i-F4 actually itong sa error no kasi gusto ko na pwedeng i-drag down ko lang tong p value no. So if I do ganyan tapos drag down natin. Hindi natin isama to. So you get ito nagbo-move yung ano natin no. Yung parang reference cells. Okay? So from here pwede tayo mag-decide no. Since p value less than and let's assume 5% na alpha no. This is significant. So usually sa table, I just like to type significant, significant, significant. Pero sa conclusion ko, I will phrase it parang ano no, the factor, the main factors, A, missile system, and B, propellant type, has a significant effect on the mean burning rate. Ganyan. Tapos the interaction of A and B is also significant. Obviously, you can state it in any way you want, no? Parang there are multiple ways of stating this. This is just how I like to state it, no? Okay? Tapos, if you compute for F-crit, you will get the same value dapat, no? So if you do equals F dot inv dot RT ng 0.05 tapos degrees of freedom here and degrees of freedom nitong as we do F4 para pag din-drag down natin siya we get ganito. So ito yung F-crit. If you notice F-calc, this is greater than this one. This is also greater than this one. This is also greater than this one. Therefore, same conclusions. No? So actually, if you do p-value, hindi nyo na kailangan ng F-crit. And if you do F-crit, hindi nyo na kailangan si p-value. No? Okay? So that's the long method. No? Now let's do the short method. So again, data analysis tool pack. And kailangan ko palang ito para kita nyo yung. So let's do data analysis tool pack. Data analysis tayo. Tapos may magpa-pop out na dialog box. Ay, sorry. Hindi pa kita. Yan. Hopefully, may nag-pop out na dialog box. Hanapin natin si Anova 2-factor pero this time with replication tayo, no? So, may difference with and without replication, no? Kasi kung without replication, hindi tayo magkakaroon ng interaction AB. Okay? Yun yung importante ng class, no? So, kung without replication, ang meron lang tayo na sources is main factor A, main factor B, tapos error total. Walang interaction AB because interaction AB can only be computed if you have replications. Okay? So without replication dapat pipiliin nyo. Pero dito sa case na to, with replication to kasi each treatment combination has 2 replicates. So with replication tayo. Okay? Nangyari. Tapos may lalabas na ganyan. Tapos dito class, naka-ano pala siya no? Sa Excel, always na kailangan by row nyo siya i-arrange. So kung ang data set na binigay sa inyo is naka by column siya, kailangan nyo i-rearrange siya. So one way to rearrange it is you can actually do something like this. No? So wale, if you have, kunwari ito yung data set nyo, tapos i-copy paste ko siya. So if I do copy, ang gagawin ko is I pick this value, itong ano no, dito sa paste special, pipiliin ko yung transpose. So what transpose does is parang if you're familiar with matrix, no, matrices, transpose is parang babaliktarin mo yung row and column, no? So parang ganyan. So dito, if you notice, naka-arrange by column na siya. So for example, ito yung data set na binigay sa inyo, no? So kunwari lang, ito yung dataset na binigay sa inyo. Tapos, kumbaga, if you do the fast method, no, itong si data analysis toolpack, hindi siya mag-work kasi uh, dapat yung replicates natin should be arranged by row. So required ni Excel na dapat by row siya, hindi pwede yung by column. Okay? So kung ganon ang case, kailangan natin i-transpose to. So what we do is copy natin siya. Tapos, if we are pasting it, we use this transpose function. So pag tinranspose natin siya, nagiging by columns na ngayon or by rows na ngayon yung data set natin. So again, dito nalilito yung mga estudyante no kung paano gamitin yung So there was an exam from previous years na parang ang binigay na data set was arranged by columns instead of by rows. Tapos biglang hindi na nagwo-work yung yung data analysis toolpack nila dahil naka-arrange by columns siya. So be very careful of that. No? So kailangan niyo siyang i-take into account. Okay? So, dito, gawin natin is since already naka-arrange naman siya by row, so okay na tong data set natin. So, we do data analysis toolpath again. Tapos, punta tayo sa Anova 2-factor with replication. Okay. Input natin yung range natin. And we should select this one, no? Tapos, dito, hindi ka pwede magkaroon ng actually yung labels. So, gagawin natin is input range lang tayo diretso na ganyan. Kasi walang parang kailangan i-tick for labels, no? Okay? So, rows per sample. So, ang ibig sabihin lang nito, ilang replicates yung meron tayo. So, for example, ito, ang each treatment combination sa meron tayo has 2 replications. So, 2 yung i-input natin dito. Let's use alpha of 0.05 and output range natin. Let's just itabi lang natin siya dito. So, output natin siya somewhere dito. Okay? We press OK. Sorry. Kailangan palang isama mo yung dataset mo. So you need to include this one. Okay. Kailangan isama mo yung labels pala. Okay? So again, eto, sama natin yung labels. Yan. So if you get that error class, no, yung parang sinasabi niya na parang ano ba yung error na yun ulit? Ay, para lang no. If you get this error, each sample must contain the same number of rows. It's because hindi natin na-select yung labels, no? So, kailangan pala isama yung labels. Okay? Sama natin yung labels. That's okay. So, meron tayong makukuha dyan. So, ito, nakalagay dito B1, B2, B3, B4. Para siyang summary lang. So, actually, hindi natin kailangan tong summary na to, no? So, what we can do is, pwede natin i-delete lang to, no? Itong summary na to. Let's delete and let's shift cells up. Para and if kung na-OC kayo tulad ko, pwede ko i-move upwards to, move upwards ulit para inline sila, no? So, meron tayong So, ibig sabihin nito, sample is the first siya yung kumbaga rows. So, for this case, pwede nating palitan into missile system kasi yan yung rows natin. Tapos yung columns natin is the columns which is propellant type in this case. interaction, this is just interaction of AB, no? Tapos, we can do A. So, you can state it like this. Pwede ring like this. So, it doesn't matter, no? Tapos, within, pag sinabing within, that's just the error, no? Tapos, total, which is same as total, no? So, you notice, we'll get the same values, no? 14.52, 40, 22, 14, 91. Tapos, doon naman sa, bakit ganun? 23. Bakit 23? Okay. Accidentally nasama ko to class, no? If you notice, nasama ko siya. Yung column totals ko. So, I can just drag this down. Drag this up. And dahil dynamic naman yung mga referencing ko sa cells, dapat magbabago lahat. So, automatic magbabago yan lahat. So, you can see na equal na sila. So, that's the parang advantage of using dynamic ranges class. No? So, instead of hard coding it, kunwari ito, I could have hard coded, kunwari itong p-value, I could have hard coded na E19 tapos pwede kong nilagay dito 2, hard coded ko yung 2, hard coded ko yung 12. Pwedeng gano'n, no? So, pagka ganun, if you made a mistake somewhere along the, yung process, kailangan yung ulitin lahat siya. Okay? So, ito yung advantage ng pag-dynamic referencing yung ginamit, no? Kasi dito, kunwari, nagkamali ako, no? I made a mistake na sinama ko yung column total. So, pag in-adjust ko yung column total na yon, lahat ng all other values ko nag-readjust siya ulit kasi dynamic yung referencing. Okay? So, you'll notice na same na siya, no? So, 23, 12, 6, 3, 2, 7.26, 13.36, tapos 3.69, 1.245, 2425. That's the same. F natin, this capital F is just the F calculated. So F calc is 5.84, 10.7, 2.9. P-value, meron din tayo. Same nyo, 0.0169, 0.0102, 0.5117, and F grade ganyan. So we can add conclusion ulit dito. And kung nahusik kayo, pwede namang copy nyo yung format nito, no? And you can also copy this format dito, no? Para maganda tingnan yung table, no? So, we can do significant, significant. So, minsan din, ito yung tinatype ko lang, no? Instead of significant, parang sig, para to signify significant siya. So, sa conclusion, this is greater than this one. This is also greater than this one. And this value, this value is not significant. So, may isa pala tayo magbabago, no? So the mean propellant rate is if you look at the p-value and look at the f calc is greater than f crit, is less than f crit, and f calc p-value is greater than alpha. No? So this now becomes not significant. Okay. Kung gusto nyo din class, no? Another way of doing this is kung gusto nyo parang i-automate din yung conclusion part, no? Para dynamic yung referencing din siya. What you can actually do is you can do an if na function, no? So if you do if this value is greater than this value, then we do significant. So we enclose it in a quotation marks kasi string siya. Tapos kung else, ito yung third argument is the else, no? Kung if the value is false, then we do not sig. Parang ganyan. So if you do drag it down, ganyan siya. So let's just say nagbago tong value, no? Kunwari biglang nagbago yung f calc natin, naging 2.4 kunwari siya. Oh, ganun. Is greater than G21. Not-sig pa rin. 0. Sorry. Not-sig talaga siya. So, kung kunwari naging 3.4 to, magiging automatic magsisignificant ulit to. Okay? So, again, you can do that pag kunwari gusto nyo talaga na dynamic lahat ng referencing nyo para at any moment na may na-realize kayo, may mali kayong ginawa, pwedeng pag binago nyo siya, automatic magbabago na lahat. Okay? So ito, the moment na nagbago, kunwari naging 27 ulit to, magiging significant. This is the result that we got earlier, no? So, magiging significant na siya. Kung 23, not significant naman siya. Okay? Tapos, if in case, kunwari, instead of 0.05, gusto natin, what happens if we do 10% na alpha? So, kung 10% alpha, magiging significant siya at 10% alpha. Okay? Pero if you don't use the long method, most likely hindi kayo magkakaroon ng error, no, kung ang ginamit nyo is yung data analysis toolpack. The problem lang with data analysis toolpack, siguro ang isang drawback is kung meron kayong hindi na na account for, kunwari nagkamali kayo sa number of rows or something. So ang mangyayari is mahirap i-recheck, no, kasi automatic ibibigay na Anova table. So in the exams, pwede bang data analysis toolpack? Yes, pwede naman, Martin. Data analysis toolpack. Just kailangan nyo lang i-maintain yung lahat ng no. So ang ginawa ko kasi dinelete ko lahat nung yung unnecessary parts. Pero kung nag-data analysis toolpack kayo, kailangan nyo i-retain yun, no, para we know as checkers na data analysis toolpack yung ginamit nyo para makuha tong table. Okay? Okay? So if you look at it, mukhang mas madali talaga yung data analysis toolpack, no? Pero I think it's also worthwhile na alamin niyo kung paano yung gamitin yung no, yung long method. So yung long method, lalo na pagka kunwari iba yung number of replicates per no. Kunwari magkaiba to. Kunwari may isang value dito. Although ito medyo complicated na to and most likely hindi naman to lalabas sa exam, no. Pero kunwari sa experiment nyo, you can only have for example, one replicate lang tong value na to. So if hindi equal yung number of replicates, actually hindi magagamit yung two-factor with replication. So ang gagawin natin dito, mag-a-adjust tayo ng denominators. So pwede sa sum total dito instead of eto ma-retain pa rin to, no? Kasi naka-count naman tayo. Ang magbabago actually is yung etong mga SSA natin, no? So instead of over 8, ang isa dito is actually over 7. Etong 211.2 over 7 lang siya. Tapos etong two others over 8. Tapos dito naman sa SSB, etong over lahat all others B1, B3 and B4 is over 6, pero dito sa B2 over 5 lang yung gagamitin natin. Okay? Tapos sa SSAB naman over 2 lahat except for this one. This now becomes over 1 lang. Okay? So yun yung advantage ng ng long method. Kaya nyong i-adjust siya depending on the needs of your data set, no. Kasi in the real world hindi naman all the time perfect yung data set natin, no. So sometimes kunwari due to lack of resources or yung kunwari yung nature ng study nyo talaga hindi nyo kayang mag-generate ng enough replicates na or hindi nyo kaya mag-generate ng replicates, equal number of replicates per treatment combination, then in those cases baka kailangan nyo mag na lang long method para mas ma-solve nyo siya. Okay? Okay, so that's two-factor ANOVA and siguro pwede ko siguro ipakita din sa inyo, no, na although napakita na sa RCBD, no, if you remember RCBD, parang napakita naman doon kung paano gamitin yung two-factor ANOVA if we assume na the blocks are the second factor, no. So doon sa cases na yun yung without replication, ang mangyayari lang is, and I could probably do it this way, no. So let's just say na ito yung data set natin. Tapos kunwari ito yung data set na nakuha natin, walang replications, no. So it's as if one replicate lang siya. So if we do data analysis toolpack, ito data analysis toolpack. Data analysis toolpack and we do ANOVA, two-factor ANOVA without replication. And mukhang kailangan natin i-adjust to, no. I'll just do it in another table, no. In another sheet, I mean. So kunwari, yan. Copy natin. Paste values. Okay? And delete natin itong additional gaps, no. So kunwari lang ito yung data set natin class, no. If we do data analysis toolpath, we do without replication. Input range natin is this one. Up to. No labels tayo, 0.05. Let's output it dito. Okay. And we press OK. If you notice, same tayo ng ano, no? Anova. Ang only difference is you'll notice na wala tayo within. Tama? Wala yung, or wala yung interaction. Okay? So meron tayong error, may rows tayo, may columns tayo, pero walang interaction. So this is actually factor A. Sorry. This is factor A, factor B, and error and total. Walang interaction. No? So you can only have an interaction na value if meron kayong replication doon sa ANOVA nyo. Whenever walang replication, ito lang yung most na pwede nyo gawin. No? Factor A, factor B, error. Okay? Okay. So, okay lang ba we take a short break, mga 5 minutes siguro, before we proceed with 2 to the K? May kailangan lang akong asikasuhin saglit, no? Mga 5 minutes lang. Okay lang ba? Martin and Russell. Thank you. Okay. So, I'll see you in around 5 minutes or gawin na natin 10 minutes para pwede kayong mag-ano din, mag-break time, no? Okay. Thank you. I'll see you in 10 minutes. Hello. Sorry. Hello everyone. Martin tsaka Russell, nandiyan na ba yun? Kabalik na ba? Okay. Okay. Sige, thank you for the feedback. So, restart tayo, no? So, before we restart, pwede siguro tayong gumawa ng isa pang example, no? Using two-way Anova, tapos try naman natin, gawa tayo ng simple lang na, no? Na using the data analysis toolpack para mas mabilis yung calculation. So, let's try this one. This is actually from a group of Math E14 students from, I believe, mga 2012 siguro to na data. So, this is from Abeleda et al. Actually, hindi ko sure pala. It could be um, earlier than that. No? So, they performed an experiment to determine whether gender and number of words have significant effects on the memory retention of UP engineering students. Tapos, shown in the table are the number of words. So, this is actually from kumbaga, from the final project na ginawa nila. No? So, shown in the table are the percent of the words remembered and the corresponding treatments analyzed at, let's analyze this at 99% confidence level. Okay? So, pwede natin copyahin yung data set natin, no? Copyahin lang natin tong table na to. Patat siya dito. Okay? Meron tayong itong percent of words. Tapos ito, this is for the May, this is the number of words, no? So that's 10, and just to be, parang hindi tayo malito, no? Gawin ko lang 10 words, tapos 15 words, and 20 words. So let's use data analysis toolpack lang, no? So this is already arranged in by rows, yung ano natin, yung replications. So if you notice there are two factors, no? Yung first factor is yung gender, and yung two levels na yun is male and female. Tapos uh, yung other factor natin is the number of words. Okay? So yung number of words natin is 10 words, 15 words, and 20 words. So ito yung three levels siya kumbaga. Okay? So let's do data analysis. General. Ito. Sorry. Ito pala siya, class. So ito siya. Itong male, female, again, ito yung first factor natin. Ito yung second factor natin, yung number of words. Okay? So, let's do, mabilis lang, no? Data analysis. This is with replication. Tapos, yung replicates natin is 1, 2, 3, 4, 5 replicates. Okay? So, let's do input natin, data set natin. Again, we include the labels, no? So, we are including the labels here. Tapos, number of rows per sample. This is just 1, 2, 3, 4, 5. 5. So, we have 5 replications and analyze daw natin at 99%. So, we do alpha 0.01. And let's output the range somewhere dito na lang. Okay? So, if we press OK, makikita natin ito yung results natin. No? So, nandito yung summary. So, kung final exam to, or exam to, wag nyo na lang iburahin tong values na to. No? Okay, but my 555 account pala to. Okay. So, we can see na dito sa Anova table, and let's add a conclusion dito, no? Conclusion. And again, just to make it look nicer, no? I-copy ko lang yung format. Ayan. Okay. So, we can see that this is at 0.01, only one is significant. Ito lang yung significant natin. Tama? All others are not significant. Not sig, not sig. Okay? So, ganun lang siya kabilis, no? Pagka if you do the data analysis toolpack, no? So, we can say that ang significant is the columns, which is yung rows kasi natin, this is the number of words. Sorry. gender, ang ano, rows, columns, rows, sorry. Gender, tapos yung columns natin is the number of words. Okay? So, ang significant lang is etong ano, no, interaction has no significant value din, no? Or it has no significant effect to the response variable. So, we can say that the number of words, which also makes sense, a lot of sense, no? Number of words to be memorized has a significant effect on the percent, on the retention na lang. Okay? So, pwede ganyan yung magiging final conclusion natin. Hmm. 0.01 0.01 naman ginamit natin, no? Ano bang tinype ko, Russell? Sorry. Okay. Kanina pa pala yan. Okay. 0.01 yung tinype ko, di ba? Okay, sige. But we can also check it dito sa p-value, no? Pwede naman p-value din yung basis natin. So, you can see na ang only value that is lower than 0.01 is this p-value right here. Okay? So, yun. That's for, I don't know, two-way ANOVA. Let's proceed with 2 to the k. And na-mention natin sa, 2 to the k dati na parang, or na-mention natin before na there are two types of experiment, or in general, there are uh, two types of experiment. Meron tayong tinatawag na variable screening experiment, tapos meron ding optimization experiment. So the first one that we've um, the first one that we've actually done is actually yung sa Anova. Is more of optimization siya, no? Kasi or modeling siya. Actually, although we didn't actually model, no? Pero later on, pagka tin-develop pa natin yung two-way Anova, pwede siya mag-proceed into optimization, no? Pero in those cases, we only did at most two levels lang, no? Tapos, or at most two factors, tapos multiple levels siya. So sometimes, kailangan kasi natin gumawa ng variable screening wherein there are multiple factors that we want to know if may effect ba siya. Pero hindi natin in particular gusto malaman kung ano yung optimum settings for those particular na factors, no? So in those cases, mas appropriate na gumawa tayo ng variable screening experiment. And variable screening experiment is often done through yung tinatawag na 2 to the k factorial experiment, no? So it's called 2 to the k because each factor, to save you sa resources, no, time and money, usually you only do two levels per factor. So kaya siya 2 to the k, this signifies the number of experiments you need to do, no? So it's 2 raised to the power of k factors. So if you do 3 factors, then you actually have 3 treatment combination. You have 8 treatment combinations, I mean. So that's 2 raised to the power of 3 is 8. So you have 8 treatment combinations to do 3 factors. Okay? So again, factorial experiment is a type of statistical experiment designed wherein the experimental runs are made at all possible combinations of the levels of the factors considered. So if we have a 2 to the k factorial experiment, then that's just saying that we have only two levels per factor setting, no? Okay? So we can do a full 2 to the k factorial experiment wherein lahat ng main effects pati yung interaction nila is we take it into consideration, pero we can also do what we call as a fractional 2 to the k factorial experiment, no? So in this case, only a fraction of the entire design is to be utilized, no? And um this is because in most cases yung higher order na interactions, no, do not actually or rarely have a significant effect. So for example, yung mga uh, third level, if you have four factors kunwari, no, yung mga three-way interactions, saka four-way interactions, rarely do they have an effect on the on the response variable, and we can oftentimes neglect them, no? So kaya kayang-kaya natin ma-reduce yung number of runs natin to 1/2, 1/4, or even 1/8 of the required size if we do if we do a fractional factorial design as opposed to a full factorial design. Okay? So ito visual representation lang to ng of a 2 to the 3 factorial design. So you have, for example, since you have sa 2 factorial design, 2 levels lang kasi we usually um, set those levels as a low level and a high level, no? Although again, arbitrary lang naman yung low and high levels, no? Kasi kunwari, if you have something like yung ginawa nating example kanina, gender, tapos ang levels natin is female and male. So hindi naman necessary na na low level ang male tapos high level ang female. So arbitrary lang talaga siya. Okay? So lalo na for cases wherein walang natural order or natural value yung factors natin. So dito you can see na the low level is usually labeled as minus, again arbitrary siya. The high level is labeled as your plus sign. So if you do a factorial design for two factors A and B, you will have 2 to the 4 siya, no? So magiging kunwari ito 2 to the 2, I mean, which gives you 4. So you have 4 runs. So you will have something that looks like this. Minus minus means that both factors are low level. So minus minus. Pag plus minus, factor A is high level, factor B is low level. And you do the different na number of ways you can arrange this itong yung plus minus na to. So you have minus minus, plus minus, minus plus, and plus plus. Okay? So, etong order na to, we call this as a standard order, no? So, if there are certain techniques that require standard order, no? So, usually kasi pag nag-experimental run tayo, dapat talaga randomize yung runs, no? So, for example, hindi 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 nyo dapat ginagawa yung experimental runs nyo na parang tuloy-tuloy to. So, kunwari, run 1 mo is low-low, run 2 is high-low, tapos run 3 is low-high, tapos yung final run is high-high. Usually, i-randomize nyo yung order na to, at saka nyo gagawin yung experiment. Pero pag ni-layout nyo na yung data nyo, there are certain techniques that require you to do standard order, no? So the way standard order works is if you have kunwari ganito siya, naka-columns yung factors natin, tas nandito yung run, naka-row yung run order natin. We always start with sa first factor alternating yung minus and plus, no? So we have minus plus minus plus. Tapos sa second na level, we do alternating siya every 2 naman, every 2 rows. So minus minus plus plus. So if you have 3 levels like this one, 3 levels to, no? So that becomes, di ba, ang factor A natin minus plus minus plus minus plus minus plus. Sa factor B, every 2 rows siya, minus minus plus plus minus minus plus plus. Tapos sa C natin, it will be per 4 naman siya. So that's 4 rows minus 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 minus, that's 4 rows plus 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 plus. So you can imagine, no, if you have more factors, kunwari D, sa D naman, it will be every 8 naman. Okay? So later I'll show you kung paano natin mas mabilis mabubuo yung standard order na yun. So through Excel. Okay? So, yung first na na gagamitin nating technique is known as Yates technique, no. So Yates technique is important sa ngayon hindi na siya ganoon ka ka necessary kasi dahil sa Excel mas mabilis na nako-compute, pero dati kasi when we needed that nung nag-pen and paper pa yung mga students, we needed a way na mas mapabilis natin yung calculation through certain algorithms, no? So Yates technique is one of those algorithms. Okay? So, ang coding system natin again is minus plus tayo. Minus for low levels, plus for high levels, no? So, it could be arbitrary, pero for certain cases pwede namang i-set nyo yung minus as the low level and plus for the high level. So, for example, ito driver type, kung regular size, that's my low level. Kung oversize, it's my high level. Ito type of ball. Ito yung medyo arbitrary, no? So hindi ko actually alam yung balata and three-piece. Pero it could go either way, no? Ito naman travel mode, we can say low level yung walking kasi mabagal siya. Tapos golf cart is high level kasi mas mabilis. Pero again, arbitrary lang to. Pwede din naman golf cart is low level, walking is high level because golf cart uses lower calories tapos walking uses higher calories. So pwede, it doesn't matter, no? Arbitrary lang naman siya. Ito, beverage, water, and beer. Doesn't matter dito, no? Pwede ngang water will be high level, beer will be low level kasi pag nag-beer ka, you can argue na mas lower performance mo and water higher performance mo. Doesn't matter pero sometimes it's just easier if you code it in such a way na mas intuitive siya, no? So, lalo na pag when we talk about engineering parameters kunwari, no? Kunwari temperature. So kung low level should be the lower temperature, high level should be the higher temperature, no? Kasi it would make little sense if ginawa natin na ang low level natin is 1,000 degrees tapos ang high level natin is 50 degrees. Parang nililito nyo lang sarili nyo pati yung readers ng paper nyo, no? Okay? Okay. So, if you use yung factors natin, usually kinocode natin siya as the capital letters. So for example, this is your treatment combination. Ito yung capital letters A, factor B, factor C, and factor D. Pagka naka-lowercase letter siya, this means this is the treatment combinations, no? So for example, if you look at this, etong one na to, this just signifies that all of the factor levels are in their low levels. So for example, si treatment combination 1 and there is a term to this, no? I forgot the term. Unity ba 'yun? I can't remember but it's probably in your modules, no? So you can read on it on your spare time. Basahin yung modules nyo on how you on what this is called, no? But this is important because in siya yung nagse-set ng kung kumbaga yung starting point ng natin, standard order. Okay? So low level lahat. Pagka whenever a factor appears, no? So for example, ito appears in its high level. So factor A is in its high level dito. And then we signify it as a kumbaga mag-appear siya doon as a small letter, no, or lowercase letter. So notice na ito, ang naka-plus lang is A, therefore small letter CA. Tapos si B dito, factor B, naka capital letter, naka shows or naka high level si factor B, therefore we call this as a treatment combination B. Tapos dito both both factor A and factors A and factor B are in their high levels, therefore magiging AB tong treatment combinations na to. So if we try to complete this, this is one method to do this, no? So parang ang sinasabi dito is if we multiply this by factor C, so kunwari 1 multiplied by factor C gives you C, A multiplied by C gives you AC, B multiplied by C gives you BC, ABC gives you ABC. Parang ganyan. And since ni-multiply mo by C, dapat mag-appear si C as a plus, no? So, tapos, and actually, ganito din, isa din to sa way na binubuo si factor, anong tawag dito? Kung paano binubuo yung standard order, no? So, pwedeng, kung you start with one group, so kunwari, A muna, so 1 and A, tapos multiply nyo by B, so that becomes B and AB. So kaya siya naging B and AB. Tapos itong 4 na to, multiply nyo by C, becomes C, AC, BC, ABC. Tapos you can imagine na ito, 8 na to get the 16 treatment combination, multiply nyo lang by D lahat. So gives you, parang ganyan. D, AD, BD, ABD, CD, ACD, BCD, and ABCD. Okay? Pero another method is, yung easier method is just do minus plus, minus plus, minus plus. Alternating dito sa A, dito alternating every 2 rows, dito naman alternating every 4, ito alternating every 8. So, depending on which you feel is more comfortable, you do that, no? I just like to do the alternating method, no? Tapos dito sa treatment combinations, ginagawa ko lang is if function lang, no, para maipalabas to. So it's always easier for me. So pakita ko sa inyo kung paano siya ginagawa. So let's do standard order muna, no. Balik tayo sa Excel natin. Let's do standard order. So kunwari lang may factors A, factor B, factor C, and factor D. Para mas madami ng factor, hanggang factor E tayo. So if it's hanggang factor E, so we have 2 to the, lagay natin, run order natin dito. So kung 2 to the E tayo, therefore we should have 32 runs. Tama? Sorry. 2. So hanggang 32 kasi it's 2 to the 5. So try natin i-buuin yung ano, no, yung standard order na to, and we do treatment here. So gawin natin is -1 plus 1 lang tayo para mas madali, no? -1 plus 1. So we can do alternating and copy cells lang natin. Okay? So that's -1 plus 1. Now I can do -1 plus 1 plus 1. Tapos ito, copyahin ko lang to siya. So I drag it down, and para ma-copy ko lang yung ano, no, yung series na yun, I'll just do copy cells instead of fill series. Okay? So you can see na every 2 naman siya dito. So dito naman -1 -1 -1 4 every 4 plus 1 hanggang 8. So pwedeng ito drag natin, and again copy cells natin. And last, hindi pala last. Ito, every 8 naman, no? So, I can do -1 hanggang 8. Tapos, 1 hanggang 16. Oh, sorry. And pwedeng copy ko to. And lastly, -1 hanggang 16. Tama? Tapos, plus 1 siya hanggang 32. Okay? So, nandito na yung ano natin. Ito na yung parang factor levels, factor settings for each of the levels, no? So we call this as the factor settings. Tapos ngayon, hanapin natin yung treatment combination na. So the first one is, we can just say, lagay natin ng apostrophe para, if you don't do the apostrophe, it treats it as a number, no? And in Excel, pagka you do a parenthesis of a number, you are saying na negative of the number yung kinukuha mo. So, eto, I don't want that, no? Gusto ko kasi na ilagay siya as parang naka-enclosing parenthesis yung 1. So, kaya nilagyan ko ng apostrophe, no? Apostrophe signifies na string yung next next numbers na isusulat ko. Okay? So, ito, gawin lang natin is, we can do an if function, no? If, we can do is equals, we can do ifs, no? No, sorry. Ang gagawin natin is concatenate pala tayo. Concat. Tapos, we do if this one is greater than 1, then we type A. Else, we type nothing. Yun yung ibig sabihin yan. Parang ganyan. Tapos, yung concat, ang sinasabi ng concat is parang i-combine mo lang yung ano, no, yung different na texts. Okay? So ito yung first text na i-combine ko, ito. So ang gawin ko is copy ko lang siya, tapos comma, kaya magkakama ako kasi magko-concatenate ako ng different text, no. So you can imagine na and dapat hindi kayo nalilito sa Excel dito. Kasi again, si concat is per argument niya is the string that you want to combine. So gusto ko kasi i-combine lahat ng kunwari A, B, C, D, E. And it depends if I have a value there or not. So kung walang value siya, magiging blank lang siya. So kaya every argument na gagawin ko is I'll enclose it in an if function. Kasi gusto ko lang mag-show siya if its value is greater, no, not greater than 1, equal to 1 pala, sorry. If its value is equal to 1. Okay? So, ang gagawin natin is, if I copy this, And this now becomes C4, no? C4. And this becomes B. Tapos comma ulit, copy ulit. This becomes C5. And this is the letter C. Tapos next is C6. Letter D naman. And last is yung let C7. Ay no, sorry. Mali-mali yung ginawa ko. Sorry, class. Hindi dapat yung letter, yung number yung binabago natin. No? C3, dapat yung letter pala. This should be D3. This should be, E3. And this should be F3. And this should be last G3. Okay? So, meron na lahat. So, concatenate lang natin lahat. So, you get something like that. So, A siya. So, if I drag this down, I get the standard order. No? So, A, B, A, B, C, A, C, B, C, A, B, C, D, etc. Okay? So, nakuha ba yun? So, ang ginawa ko lang is nag-if function lang ako tapos para malaman kung ilalabas ko ba yung letter niya, yung small letter niya or uh, or tapos after nag-if function ko, after sa if function ko, i-concatenate ko lang, meaning i-combine ko lang yung different strings na yun. So dito lumabas si A, lumabas din si B, combine ko sila, naging AB siya. Tapos since ang if function ko is either A or blank siya, therefore nung nag-negative, blank siya, so parang A, B, tas blank, 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 blank. So magiging AB lang yung final na ano niya. Okay? Okay. Thank you, Martin. No? Hindi natin nagawang E to. So E. So ulitin natin, drag down. Now you get ito. You get the standard na order, no? Okay? So ito, this is for me the easiest way to do this, no? Pero pwede naman kunwari low number of factors lang, pwede namang i-manual nyo na lang, no? Tingnan nyo na lang siya. Kunwari lumabas si A, lumabas si B, lumabas si AB, lumabas si C. Ganun, pwede namang i-manual nyo na lang. That could also be an option. I just like to do it this way, no? Kasi mas mabilis siya. Okay? Okay, so balik tayo dito. So, let's try this example, no? Meron tayong example na 2 to the k experiment to, where we have ABC. Tapos usually ganito yung if we do a 2 to the k experiment, usually we want to parang if we are showing the yung parang factor settings of our experiment, usually we represent it this way, no? So meron tayong coded factors, yung run, yung kung anong factors na yun, A, B, C, tapos -1, ganyan. So ito yung standard order niya. Tapos nandito yung yield value, yung response natin, which is our yield, no? So in this case, H rate yun. So we have replicate 1, replicate 2. Tapos nakalagay din dito yung factor levels. So sometimes hinihiwalay yung factor levels, no? Pwedeng kunwari table 6.4 to, tapos ang factor levels is table 6.5. Pwede din naman yun, no? Pero usually pag nag-experiment kayo, kailangan nyo ipakita to, no? Yung coded factors nyo, tapos ano yung naging results, tapos kung ano yung maging factor levels nyo. So you have your low setting, yung -1 natin is for the uh, gap. Yung factor A is the gap, factor B is the C2F6 flow or measured in SCCM. Tapos actually hindi ko masyadong alam tong mga ano to, no? Kasi plasma technology to, hindi ako expert, pero uh, even though we are not experts of plasma technology, kaya din natin ma-analyze yung results nila, no? Dahil marunong tayo mag 2 to the K design. So itong C is power measured in watts. So ito yung low setting niya, ito yung high setting niya. Notice na since ito may exact value sila, no, pwede nilang ilagay sa low value yung kumbaga lower value. Tapos yung sa high setting, ilalagay nila yung higher value. So 0.8 cm, 1.2 cm para factor A. For C2F6 flow, it's 125 SCCM. I don't know these units, no? And 200 SCCM yung sa high setting. Tapos sa power naman, 275 watts for the low, 325 watts for the high. Dito, for now, dahil nag-2K design lang tayo, we are just looking at kung ano yung, anong tawag dito? Kung ano yung parang um, significant factors or non-significant factors. Hindi actually natin concern masyado tong values na to. No? We call these values actually as the natural settings. No? Natural meaning kung ano yung actual settings niya dun sa experiment. And we call these settings as the coded settings. No? So we have coded settings, natural settings. Okay? So, pero pag nag-proceed tayo sa optimization, tsaka yung mga, ano no, yung pag nagmo-modeling tayo, we now are able to do or we need to use this natural settings. No? For now, hindi muna natin gagamitin siya. Okay? So, let's try to do this. We can do, um, i-set up lang natin muna yung, ano no, yung, ang tawag dito, Yates table muna. Okay. Okay, inuna pala niya yung effects, using effects. Sige, una muna tayo sa effects, no? Instead of Yates na technique. So, dito sa ano natin, um, sa first technique, meron tayong tinatawag na table of signs muna, no? So, we do table of signs. Tapos, from the table of signs, we can compute for what we call as an effect, no? So, yung effect natin is calculated by multiplying the contrast by 2 divided by 2 to the k over n. Tapos, from the, itong effects parang, ano lang siya, no, a rough indicator of how it how the factor either positively or negatively affects the yield value, no, or the response variable. So for example, itong effect A, if it's a very large negative value, no, so meaning it has a large negative effect on the response variable. Tapos si factor B, you can see that it's a small positive value, so meron siyang small positive effect. Pero the effects do not tell us if it's statistically significant or not, no? So para mag-compute yun, kailangan pa rin natin mag-Anova table using sum of squares. So from the contrast, kasi pwede natin mag-compute din yung sum of squares, no? So the sum of squares is equal to contrast squared divided by 2 to the k over n. So to compute for contrast, equal lang siya sa uh, pagka parang i-add lang natin lahat ng parang values that are, hindi ko masyado ma-explain siya, no? Pero later, pagka nakita nyo sa table, mas mag-make sense, no? Pero parang sinasabi lang, whenever the setting or the factor is in its high setting, we assign it as a positive value. Tapos kung nasa low setting siya, we assign it as a negative value. So for example, nung treatment combination A, that is a setting that has a high setting si factor A. Therefore, positive value yung i-assign natin sa kanya. So, whatever yield na nakuha natin, so for example, dito sa table na to, etong si factor A is 1319, kunwari dito, no? 1319. Therefore, positive 1319 siya. Tapos, yung second factor, yung treatment combination na to, which is negative, negative si factor A, i-minus naman natin to. So, plus ito, minus to kasi low setting si B, plus dito kasi high setting si A, minus dito, low setting si A, high setting si A, therefore plus siya dito, and so on and so forth. Parang ganun siya, no? So, to facilitate calculation of this, it's important na gumawa tayo ng tinatawag na table of signs, no? So yung table of signs is just yung a faster way of computing, no? Kasi since may table of signs na tayo, pwede tayong gumamit ng tinatawag na sum product, no? So si Excel kasi may sum product siya na formula, and the sum product will give us a, a faster way of computing different differently signed values, no? Kasi if you do sum product, ang ginagawa kasi ng sum product is they multiply the values first before adding it. So this will be useful for us, no? Kasi kumbaga ang kailangan kasi natin is pagka positive si A, i-add natin. Pagka negative si B, pagka negative low setting si A, i-minus natin. So, pwedeng from the table of signs, since mayroon tayong minus and plus, pwede actually i-sum product na lang natin. Tama? Kasi try to think about it. Kung naka-negative si A, if we do sum product, so i-add natin yung negative value for that particular na setting. Okay? So, later, pagka nakita nyo yung Excel, it will make a lot more sense. No? Pero for this, we need table of signs and the sum product na equation or the sum product function. Okay? So, let's do first. Saan yung table natin? Parang may mali dito. No? Dito sa sample calculations niya, you can see na sa contrast for A niya, 1219 ang A. Pero doon sa table, it's actually 1319. So baka nagkamali lang to, no? Ng ano. So let's recalculate. 1154. Tama naman yung iba niya. 1154. 1154. 1234 ang B. Let's see. Si B is 1234. Baka ito lang yung particular value nagkamali siya, no? Pero let's check. Wala tayong, unfortunately, ano to, no? Uh, picture siya. So, we'll have to input it manually. No? So, try lang natin. So, let's do replicate tayo. So, this is, let's just do Y, H rate. Tapos, meron tayong 2 replicates. No? So, we have 550, 604, and just inform me kung may mali ako na type. Kasa 650, 633, 601, 642, 635, 1037, 1052, 749, 868, tapos 1075, 1063, 729, and 860. Okay? Okay. So, thank you, Russell. So, ito yung ano natin, no? So, in-encode ko lang manually kasi naka-picture kasi ito. So, kaya in-encode ko na lang manually yung different values. Okay? So, ang gawin natin is, kailangan natin yung table of signs muna, no? So, let's do the table of signs. And probably we can move this, move natin to the right. We have 3 factors. So, therefore, yung table of signs natin should be, we do A, tapos B, C, tapos we do AB, we do AC, and we do, ano pa bang kulang? Okay. BC, tama? And we do ABC. Yan yung kailangan natin. So, if it's a standard order, di ba, ang ginagawa natin is, let's do, ano no, minus 1, minus 1, minus 1, tapos plus 1 naman to. Tapos, copy natin hanggang 8 values. Tama? Tapos, we do hanggang, ano to, 2 values, minus 1, plus 1, plus 1, and we can just copy this one. Okay, tapos ito naman is minus 1, minus 1, minus 1. Tapos, puro plus 1 naman sa baba, lower half. Okay? Tapos, itong AB is just a, multiply lang natin yung A times B. Parang, it's as simple as that, no? So, kung low factor parehas, AB is a positive value. Parang ganyan. AC, we just multiply A times C. Okay? Tapos, BC naman natin, we do, BC is B times C. Ayan. Nakikita ba? O i-zoom in ko konti para mas makita nyo. No? Tapos ABC naman is just A times B times C. Okay? So, ayan siya. Tapos, itong standard order, what we can do is, itong treatment, no? I can just do what I did earlier, no? So, ang kailangan lang naman is ABC. So, we can just do, etong number 1 is just, ayan siya. So, I can do, center ko lang to. Tapos, ito, I can do manually or pwedeng gamitin ko yung concat ulit, no? Concat, if this cell, sorry, concat, sometimes minsan mas mabagal kung nag-ano ka pa, no? Nag-if function ka. Lalo na pag small number. So, sige, pwede sigurong hindi tayo mag-concat or pwede rin cap. Since gumawa na tayo ng concat function dito, pwede naman copyin ko na lang to, no? Yung concat function na to. Tapos, lagay ko lang, para mas mabilis, no? Tapos, we do C3, pero tanggalin natin yung hanggang C lang kasi tayo, no? So, pwede natin tanggalin hanggang dito. Ganyan. Sorry. Kasi, i-move natin to dito. Yeah. Tama. So, I can just do this, no? So, pero kayo, depends on you. Pwede naman sigurong kung comfortable kayo na manually, pwede naman manual, no? Okay? So, eto siya. So, ang gawin natin is, let's compute for contrast first, no? So, I like to do it this way. So, ilalagay ko dito sa baba para pag nag-compute ako, dire-diretso na. And let me just, adjust. Move ko dito. Then I can probably do totals, no? So, ito, merge natin. Let's rate totals natin equals, just do ito plus ito. So, again, ang goal natin is, when we do contrast calculations, gusto kasi natin na whenever negative siya dito, ima-minus natin whatever value na nandito. Okay? Tapos kung positive siya, ipa-plus natin siya. Okay? So, if we were to compute the contrast, pwedeng sum product yung gamitin natin. So, the way sum product works is, sum product, yung array na to, I'll multiply it with this array, to totals. Okay? So, what I'm trying to say here is, gusto ko na, eto, kunwari, negative 1 times 1154 plus 1 times 1319 plus negative 1 times 1234. In effect, parang nangyayari is, nama-minus yung whatever low setting, kung low setting si A, tapos napa-plus yung pagka high setting si A. So that's why sum product is very useful in this scenario, no? Okay? Tapos eventually gusto ko kasi i-drag na lang tong function na to. So therefore, eto gusto ko mag-move tong blue array na to to the right whenever I drag it. Pero ayaw ko mag-move tong red array, no? So pwedeng ang gawin ko is i-dollar sign ko to. Okay? So i-fix ko using F4 para if I do this, drag ko to the right, I get these values, no? So ito na yung contrast values ko. So we can compute for fx. Fx is equal to this one multiplied by 2 divided by yung total na observations, no? Which is just, I'll just do count, no? Kasi mas madali siya. Count, ganyan. And I want to be able to drag this, so pwedeng i-F4 ko na lang to. Okay? So, I can do something like this, no? So, i-double check lang natin doon sa ano natin. Kung same ba tayo na nakuha ang values. FX 101.625. Tama naman yung nakuha niya, no? So, baka typo lang talaga etong value na to. Pero negative 813 and negative 813 rin naman ang contrast. So, siguro malamang na mistype lang niya to, pero tama naman yung final answer, kumbaga. Okay? So, eto, we have the FX. Kailangan lang natin is yung more important is the contrast, no? So, or sorry, more important is the sum of squares. So, sum of squares is equal to eto squared divided by count nito. Okay? And again, gusto ko i-F4 na lang to. Or pwede rin i-hardcode nyo na lang, no? Instead of using count, pwede namang, there are 8 treatment combinations multiplied by 2, 16. Over 16 lang naman to. Okay? Minsan, mas madali lang. For me, no? Mas madali lang na i-count ko na lang as opposed to, So I get the sum of squares. And let's double check kung same tayo ng sum of squares. 41,310. 40, ay, okay ba? Hmm, parang may mali sa ano yan. No? Ah, sorry. Kasi yung effects yung skinner ko. Dapat ito. Okay, that makes a lot more sense. No? Effect, kasi SS is contrast squared, hindi effect squared. No? So mali yung ni-reference ko na cells. Okay? So this will be the same na. No? Kaya 41, 217, 378, etc. Ayan. It's the same value. Okay? Now I can begin to build my Anova table. No? So Anova, again, source, SS, DF, MS, FCalc, and p-value. So hindi ko na ilalagay yung fcrit, no, kasi I'll just be using the p-value, no, conclusion. And for ano pala class, no, 2 to the k, as far as I know, wala si Excel ng parang ano, no, quick method sa data analysis toolpack. Wala siyang uh, fast method to do this. So kailangan gawin nyo siya talaga manually, no, either through table of science or through Yates technique, which is ituturo ko naman yung Yates technique mamaya, no. So let's do table of science muna. Uh, uh, and this is my preferred method, no? Ito table of science kasi mas madali siyang i-calculate. Okay? So, gawin natin is from here, we do source. Source natin is A, B. Actually, pwede ko i-copy ito, no? So, copy. So, gawin natin is paste and we do transpose. Okay? So, pwede ganyan. Tama? Tapos, some like to label it, no? So, yung iba, ginugrupan nila parang ito yung two-way. Ito yung main. Pwede rin i-ganito na siya, no? So, i-ano natin kung para consistent. Pwede ganyan. Ito yung main, two-way, tapos itong last is the three-way interaction. Three-way. Okay? So, yung iba, ganito nila nililayout para mas malinis. No? You can also do it this way. Tapos, error, and we have total. Okay? So, main natin is, if you want to do this, pwede namang equals ito. Ganyan, manual nyo na lang, equals. So, again, I'm doing dynamic, no? Doing dynamic na ano, referencing para if in case may mali akong value na input, kaya kong ma-check siya eventually, no? Tapos last is ABC. Okay? And total is computed the same way, no? It's sum squared ng observations, which is this one, minus the correction factor. And the correction factor is just the sum of this one squared divided by, so yan, sum square nito minus correction factor natin is total, grand total, sum nito, or pwede nga gawin natin is instead of that one, pwede na naman ito, no? It will give us the same value. Sum, sorry, dapat mali. Hindi pwede yun kasi yung blue, yung red dapat yung binago ko, no? Pero sige, balik ko na lang sa luma dati. So, sum squared nito plus minus sum ng yung grand total square divided by total number of observations, which is count ito. Or you can do 16. Okay, so this should be your total. And if I do error and to double check, no, tingnan natin kung same tayo ng total. Doon sa wala siyang binigay. Hindi ko ma-check, no. Pero tama to. Sum squared sum squared nito minus correction factor, which is this one. Sum total square divided by count. Tama naman. So, the way you check it, kung tama yung ginawa nyo is dapat yung error nyo hindi magne-negative. Usually, nagkakamali pag negative yung lumalabas na error. No? So, I can do equals minus ito, total minus the sum of all of these values. So, it's a positive value which gives me confidence na tama yung ginawa kong equations. No? Okay? So, you can do df. Df is equal to yung number of levels kasi since this is a 2 to the k experiment, all levels is just 1, no? All DF is just 1 kasi 2 minus 1 lang yun. Tapos, pag kunwari two-way interaction, 1 times 1 lang naman siya kasi factor A times factor B. Degrees of freedom factor A times degrees of freedom factor B. So, 1 lang din lahat to. Tapos ito, same way, 1 lang din to. And kung na-OC kayo, pwede namang ako na-OC ako. No? So, i-separate ko siya para may error ako dito. Okay, so ito, total natin is equal to count. Let's just say count ito. And notice na I'm counting all of the observations class now. So this means plus the replicates. So hindi dito sa totals ako nag-count. Okay, so count yan minus 1. Okay, so I have count 15. Now for error, this will now be just equal to, and I can drag this actually, no? Kasi same lang siya ng formula. Yan. Okay, so this becomes 8. So that's 15 minus 1 times, ilan ba to? Total, this is 7. So 15 minus 7 gives us 8. Okay, tapos MS, it's always SS over DF. Pwede ko i-drag down siya. MS over DF plus dito. Tapos delete na lang natin tong ano to. Okay? Yung iba pala class, and maybe you're more comfortable with this also, no? Yung iba, instead of doing this, ginagawa nila is para hindi bungi, no? Ginagawa nila is ganito. Parang ganyan. Para mas madali mag, ano, no? Parang mas madali mag-drag. So, pwedeng ganito din yung way ng pag-ano nyo. You can do it either way, no? I think this looks much nicer, no, and cleaner. So, let's do it this way. So, Fcalc natin is just MS ang source divided by MS error. And again, MS error is always the divisor. Therefore, gawin ko siyang $sign. Para pag dinrag ko siya, it gives me my F calculated. Now, P value is equal to F.list.rt. Again, right tail parati tayo, no? Ng this one. Degrees of freedom 1 is this. Degrees of freedom 2 is the denominator. And again, F4 to fix it, no? Para I can drag it down. Okay, nag-delete lang natin to. And since there are multiple, I can do a function, no? Para mas madali. If P value, this value is less than 0.05, then I'll say that it is significant. If it's not less than 0.5, then it is not significant. Para pwedeng diretso na, no? Gawin ko, drag ko na lang pababa. So, automatic, significant, 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 not sig, not sig. So, pwedeng conclusion natin is main factor A, sorry, ano ba itong A? Gap ata itong A. A is gap. So, the gap and power. The gap and power have significant, are significant. And power significantly, pwede naman ganyan, significantly affects the etch rate. Pwede ganyan, no? Tapos, the interaction between AC, so that's AC, no? AC is gap. Their interaction is also significant. So, pwedeng ganyan yung ano nyo. Pwedeng ganito yung magiging final conclusion nyo. Tapos, all other hindi na significant. Okay? So, that's how you do table of signs. Now, let's do Yates naman, no? So, for Yates, let's do another example na lang. Ito. This is your Yates. Let's do this example, no? And ito maganda kasi naka table na siya, no? So, pwedeng compute natin siya ganyan. So, again, Yates technique is a sort of ano lang class, no? A way to an algorithm para mas mabilis ma-solve yung contrast, no? And from contrast, pwede ka na mag-solve ng ng SS. Okay? So, for SS, for Yates, kailangan naka-standard order siya, no? Notice dito sa table of signs. So, if I go back to the table of signs, no? Notice sa table of signs, hindi nagmamatter actually kung no? Naka-standard order or not kasi magbabago lang din naman yung parang values niya. So, kunwari, ito, if this were placed, kunwari, ito, nagbago siya, ginawa natin at the bottom to. Kunwari, -1, ah, kunwari lang binago natin yung order na to, no? Magre-reflect din naman siya dito sa contrast kasi naka-sum product naman tayo. So, hindi nagmamatter kung naka-standard order or not si table of signs. Pero dito sa Yates technique, it requires na when we do the algorithm na table of signs, naka-standard order siya. So, the way it works is, itong sa table of signs, no? Is kunin niyo muna yung total tapos magse-set up kayo ng number of columns equal to the number of factors. Okay? So ito, for example, we have 4 factors, A, B, C, and D. So therefore, nagdagdag siya ng 4 additional columns. If 3 factors lang yun, dagdag lang tayo ng 3 additional columns. Okay? So, ang gagawin natin is yung upper half, magdadagdag tayo ng or i-add natin yung mga parang magkasunod na rows. Okay? Tapos doon sa lower half, kukunin natin yung difference between consecutive pairs. Okay? So para mangyayari is parang ganyan. So this is just itong first column na to is dinagdag mo lang yung ito plus ito. So that gives you 118. Tapos itong 103 comes from 50 plus 53.1. 50.1 plus 53. So yan nyo. Tapos dito sa second column, it's 1 because that's i-minus nyo kukunin nyo yung difference between yung second row minus the first row. So ito 59.9 minus 58.9. Tapos itong 3 is 53.1 minus 50.1. And itong 2.5 it's 50, sana tayo dito 50.7 minus 48.2. So by pair tayo, nag-move yung pair natin kumbaga. Okay? So, pwede yung manual siyang gawin. Pero, meron akong technique na ginagawa, no? I do, which requires na may certain manipulation kayo dito, no? So, let me try to, I'll try to remember kung ano yung technique na ginagamit ko. So, kasi ang pwede natin gawin is, di ba, magdadagdag tayo ng 2, 3, 4 columns. Okay? Tapos i-add natin kasi medyo arduous din. Let's do totals muna, no? So if I do ito plus ito, so we can do something like this. So pwede rin kasi ang gawin natin is, parang ganito, no? So plus, ganyan, pwedeng ganyan, no? Kaso ang mangyayari is, baka nakakaduling siya minsan, no? Kasi hindi nyo alam, kunwari ito, nasaan na ba kung tumigil dito ba or dito, parang ganyan. So it can be sometimes difficult, no? So kunwari ito, nasa 6 na ako dapat, ganyan. So sometimes, medyo confusing siya, no? So what I like to do is, I'll make use of yung, ang gagawin natin is we want to add the the first pair, no? Tapos yung pair natin nagmo-move siya downwards. Tama? So, ang easiest way to do this is, paano nga ulit to? I can assign numbers, no? So, pwedeng gawin ko is I can do something like, ganyan. 8, 8. Tama ba to? Let me check kung ito nga yung, I can remove these totals here. Ito nga ba yung ginawa ko? I'm trying to remember the class, no? Yung easier way to do this. Kasi may algorithm ako dito eh. Tama ba? Kasi I want to add consecutive pairs. So I can do equals. Baka mas maalala kong wait lang class ah. Let me first find my ano. Meron ako nagawa dito. Let me find my old ano no. Saan ko ba nilagay yun? Yates technique. Okay. Saglit lang kasa. Iniisip ko kung faster method. Pero sige, while I'm thinking about the faster method, no, pwede naman sigurong yung shorter, yung ano, long method, no? Ito lang kasi, ang issue ko lang dito is nakakalito minsan kung nasaan ka tumigil, no? So, ito. So, kunwari dito, 52.6 plus dito ka na. Tapos equals dito plus ito. But the good thing about this is once, no, sorry. Ito na yung nagkakamali ako, no. Kasi minsan, hindi mo na alam kung saan ka tumigil. So, prone to error siya. Ganyan, equals, tapos yung last pair. So, posible na may mali akong nagawa somewhere along the line, no? So, I can double check. 3, 3, 4, 4. 5, 5. Parang kulang. Wait lang. 1, 1, 2, 2, 2, 2, 3, 3, 4, 4. Nag-skip ako. Dapat dito muna, no? 5, 5. Tapos 6, 6. Tapos 7, 7. Tapos 8, 8. Itong last pair na to. 8, 8. Okay? Tapos, ito naman, dito sa lower half naman, we do minus naman natin yung pairs, no? So, we can do ito minus this one equals this one minus this one. Ito, this is 3, 3. So, ito minus 3. Ito, 4, 4, no? This one minus 4 equals this one minus 5 equals saan na tayo? 6 na tayo, no? So, 6. So, 6 equals 7, which is this. Minus it. Pagka naalala ko yung ano class, no? Yung faster algorithm ko dito, papakita ko sa inyo. Then, let's double check, no? So, that's this one minus ito sa taas. 2, 2, 3, 3, 4, 4, 5, 5. This is 6, 6. So I'm just referring to my ano no, itong nilagay ko na parang ano para mas mabilis ko makita kung tamang pair ba yung kunan ko ng difference. And we have 8, 8. Okay, mukhang tama naman. Now, since ang gagawin natin is we do the algorithm again 4 times. So if I drag this to the right, so ito, ang gagawin niya is i-add naman niya yung next pair. So hanggang umabot sa 4. And actually, ito yung contrast na natin. Okay? So this, the fourth one will actually be your contrast. And pwede na mag-compute ka ng effects and SS. Okay? So ito, effects and SS, no? So effects is just equal to times 2 over count nito. Count ng 2 replicates na ito. So that is our effects. No, sorry. Hindi ko na $sign. I should place a $sign. No? Yan. Tapos effects, SS ko is equal to this one squared divided by count nito. And let's do $signs again. 4. Okay? And let's double check no kung same tayo na nakuha. 11.2. Same naman. Contrast and sorry. Ito, this is the first one kasi ito pala yung first run order natin, no? This will just be equal to the total sum, no? So if you get the total sum, ayan, it's 865. So that is one way to check if tama yung ginawa niyo, no? If the first value is equal to the total, then you did the correct algorithm, no? Okay? So, this is actually an effect. So, hindi natin siya i-compute na. Dito tayo mag-start ng SS natin. Okay? So, let's try to look at kung tama ba yung same ba tayo na kung value. Negative 1.2, negative 1.225. Okay, so same naman. Then, for the SS, 11.52, 12.01, 11.52, 12.01, 7.8, 7.8. Okay, same naman yung nakuha nating value. And we can build the Anova table from here, no? Let's try to do, but before we build the Anova table, no? Try naman natin i-compare kung table of signs yung ginamit natin, kung easier ba. So what we can actually do is insert tayo ng multiple cells dito. And we do A. Sobrang dami pala nito. Sige, try natin, no? This is more challenging kasi ang daming natin. So we can have A, A, B, C, and D. Tapos A, B, A, C, A, D, and B, C, B, B, C, B, D, and ano bang kulang ko? A, D. Nakuha ko na ba? Lahat? Wait lang. Tama ba to? Is there 3 ways? Equals combine. So, one way to check it. No? Combine. We have 3 taken. We have 4. We take it 2 at a time. Gives us 6. No, sama. 6 values. No? Okay. So, next is ABAD. Kulang pa tayo. Okay. So, meron pa tayong 3-way interaction. So, that's ABC, ABD, tapos ACD. Ayan na tayong tatlo. Tayo na combine. 4 taken 3 at a time should be 4. Kulang pa tayo ng isa pala. Sorry. Anong hindi ko na-account? ABC, ABD, ACD, and BCD. Tama, no? Yun na ba yung kulang? BCD. Okay. So, we have 4. Tapos, yung last is yung 4-way interaction which is ABCD. Okay? So, build natin yung table of signs natin. So, we can do negative 1. Tapos positive 1. Tapos copy natin to hanggang ganyan. Hanggang dito, no? Ba't ganun? I-drag ko na nga lang. Copy cells. Mhm. Tama ba 'to? Lagay lang ako ng ano 'no, para tingnan ko kung tama. Mali. Hanggang 16 lang tayo. 16 run order tayo. Okay? Tapos balik kong kopyahin na siguro 'to. Diretso na lang ganyan. Yan. Okay? Tapos eto, since standard order naman 'to, I can do yung ano 'no, alternating lang. So ito negative 1, tapos positive 1, positive 1. Yan. Copy cells. Tapos si C is negative 1. Tapos hanggang 8. No? 2, 3, 1, 2, 3. Let's copy natin to. And lastly, ito puro negative 1 sa taas. No? Okay. Tapos dito naman puro positive 1. Ganyan. Okay. Tapos ito equals A times B. Drag it down. Ito equals A times C. Ito equals A times D. Ito B times C. Ito lang siguro yung mahirap sa ano, no? Table of signs. Yung pagbuo nito. B times D equals A times D. Ito equals ABC. A times B times C. Ito A times B times D. And then we have A times C times D. Sabihin niyo lang kung may mali kayo na spot class, no? Ito naman, last natin, B times C times D. Tapos ABCD is just A times B times C. And you can play around with Excel, no? Kasi baka may ma-discover kayong faster way to do this, no? Using certain formulas. But ito, na-build na natin yung table of signs. So what we actually just need to do is, kailangan lang natin yung contrast, which is sum product lang, no? Contrast. So we can do equals sum product ng array na to multiplied by this array, the totals array. No? And we do F4 para ma-fix natin siya. Okay? And if we drag it to the right, we can compare, no? We should have the same value. So if you look at it, contrast 19, negative 19.2, negative 19.2, negative 19.6, 19.6, etc. So we get the same value, no? And if we do fx equals this one times times 2 divided by 16, 32 actually, 32. Let's just do count. Count nito. Tapos yung last natin is yung SS, no? Equals contrast squared divided by count nitong values na to. Okay? Tapos we can do drag it out. And we should get the same contrast values dito, no? And para lang ma-check ko, no? I can do copy ko to. Paste values ko such that naka-transpose siya. So I can do paste special, values only, and transpose para easily ma-compare ko lang siya. No? Magkaiba yung... hindi. Kasi ito kasi naka-arrange to in standard order. No? Pero ito sa akin, A, B, C, D, dire-diretso to eh. Na parang from one way, two way. So kaya hindi nagmamatch exactly siya, no? So, hindi natin mako-compare siya ng ganyan. So, dito, if we were to build the ANOVA table, and this is one way you can do this class, no? So, for example, Yates technique yung ginamit natin. And we have proven na same lang yung nakuha sa Yates and sa, ano, no? Sa table of signs. So, if we do Yates technique, pwede ang gawin natin is ANOVA. We have source, SS, DF, MS, FCalc, P value. Tapos conclusion. Tapos ito sa source, usually we like to do A, B, C, D. So kumbaga mas maganda kung yung similar sa table of signs, no, na nakahiwalay yung mga ano natin. So if I just copy this, tapos paste special transpose, mas maganda kung nakaganito siya, no? Kasi at least nakahiwalay yung mga nakahiwalay yung different uh, main effects and two-way effects, no? So ito two-way interactions, ito three-way, and last is yung four-way interactions. Okay? So the problem is if we try to do ito, pag kinopy-paste nyo lang siya papunta dito, hindi siya nagmamatch, no? Kasi ito naka-standard order kasi siya. Kumbaga A, B, C. Ganyan. So what the easiest way to do this is actually pwede nyong gawin is equals, we do a function, no? Tawag natin is the Vlookup function. So Vlookup is hahanapin natin to. So we look at the table, although ito kasi nakaano to, no? So kailangan natin i-lower muna siya. So ang gawin natin is Vlookup. Lookup value natin is we do lower. So ibig sabihin kino-convert natin tong capital letter na to into a lower text para mag-match siya dito. So the first argument sa VLOOKUP is hahanapin mo uh, yung particular value na to, itong si A, dito sa column na to. Okay? Tapos hanapin natin siya, yung second argument is the table array, and we need to choose a table array that gives us what we are looking for. No? So ito yung table array natin. The first column should be where you want your lookup value to or where you want to look up dun sa value na pinili nyo. Okay? So, kumbaga, ito yung lookup value natin is A, no? Gusto natin hanapin siya dito sa column na to. Okay? So, kaya natin dinagdagan ng lower kasi dito naka-lowercase, ito naka-uppercase. Okay? So, ito, column index number is yung kung ano yung gusto natin ano, no? I-return na column value. So, kumbaga kung mahanap niya si A, kunwari, hanapin ko to si A, ito siya, hanapin ko. Gusto ko i-return niya yung SS. Okay? So, if you look at it, nasa ilan to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th column siya. So, pwedeng gawin ko is column index number 10. And yung last na ano is I want an exact match, no? So, I'll do false. Kasi kung true yung ginamit natin, pwedeng mag-approximate siya and that's not what we want, no? So, pwedeng ganyan. And what we can do, i-F4 natin tong array na to, no? Para hindi siya magbabago. Okay? So, it returns 11.52. And notice, pag dinrag down ko siya, it will return to me exactly the values I want to look for. Mari, si AC. AC is this one, AC. You'll notice na si AC is 3.011000125. Then you have 3.00125. So, again, totally unnecessary itong VLOOKUP function is just a parang quality of life improvement. No? Mas mabilis lang makapag find kayo ng SS value. Pero if you're comfortable with Excel, pwede naman kung ayaw nyo mag-VLOOKUP, no, pwedeng gawin nyo lang equals, ganyan. Tapos hanapin nyo si B, which is this one. Tapos si C, nandito siya. Pero again, dahil standard order to, medyo nakakalito, no? So, unlike, pero pagka table of signs yung ginamit nyo, since dito, usually naka-layout na to, naka-group na siya into main, two-way, and three-way, pwede nang i-transpose nyo na lang tong values na to. SS, transpose nyo lang dito, no? Or pwedeng dire-diretso lang yung equals nyo dyan. Okay? So, depends on you guys kung ano yung comfortable kayo. You can use VLOOKUP. Actually, may mas faster way pa, no? Instead of VLOOKUP or in terms of computing sa ano, no, lalo na pag medyo mabagal yung computer nyo or yung laptop nyo, pwede naman instead of VLOOKUP, kasi VLOOKUP uses more resources, no, as compared to yung tinatawag na index match, no. So yung another way of doing this, instead of VLOOKUP, pwede ring index match yung gagamitin nating function, no. So just to show you, lagay ko lang dito, no, add lang ako ng another column, insert shift cells to the right, add lang ako ng SS pa rin to, no, pero this is through index match. So sabihin ko lang na index match ginamit ko dito. Kasi ito, VLOOKUP. VLOOKUP. Okay? So sa index match, mas mabilis siya. Ang gagawin natin is index, tapos yung first na reference natin is yung ano yung hahanapin nating value, no? So gusto kasi natin hanapin tong etong particular na gusto natin sa si SS yung i-return natin. So pipiliin natin si SS dito. And actually hanggang dito lang, no? Kasi hindi naman kasama si 1 index. Tapos ang i-return natin is kailangan natin i-match yung lookup value na to. Ito, and again, i-lower natin siya. Lower. This one. Tapos, ang lookup array natin is this value. And hanggang dyan lang. Tapos, gawin natin is false. So, parang sinasabi dito is, yung index match, combination siya ng index tsaka match na function. No? So, match function is just, hanapin niya yung A, hanapin niya kung nasaan siyang, kung aling row siya dito sa array na to. Tapos, yung index is, i-return niya yung, etong sa ano natin, return column natin, hanapin niya kung ano man yung lumabas sa match result. So, kunwari, etong A, lumabas na sa first row siya doon sa index natin. So therefore, index na yung return column natin, first row, this is the row that I'm looking for. So kaya nag-work siya. It's similar to VLOOKUP, pero ang maganda lang sa kanya is sorry, hindi ko kasi ni F4 to. Dapat F4 ko tong values na to, no, para ma-fix siya. Okay, tapos pati itong index, no, kailangan kong i-F4 to. Okay? So pwedeng i-drag down ko siya ng ganyan. And you'll notice, same lang yung nakukuhang results, no? Some students like VLOOKUP kasi mas intuitive siya, no? Parang hinahanap mo yung one value among a table sa first column, tapos i-return mo yung results sa chosen column. And in this case, yung 10th column, no? So some students like this, some students like this index match kasi mas malinis siya tingnan, no? If you do index match, so depends on you guys kung ano yung gusto nyo. But it should return to you the same value. And if you're having trouble with index match or VLOOKUP, pwede naman manual nyo na lang siyang gawin. Parang hanapin nyo A, hanapin nyo kung nasan si A dyan, B, nasan si B, etc. etc. Okay? So let's just continue this, no? Ito, SS, same value lang naman to. So we have one lang to lahat, no? Kasi we have 2 factor levels. And let's do error and total. So, si factor level naman natin is just equal to, 2 kasi 2 to the k design to. So, 2 minus 1 is just 1. And lahat naman to, kunwari, ABD is just the product of the degrees of freedom of A, B, and D. So, therefore, 1 times 1 times 1 lang naman yun. So, kaya 1 lang to lahat. So, error natin, ang total natin is equal to sum square ng replications, ito, observations natin, minus the correction factor which is just sum, grand total nito, squared divided by count nito. Tama? So that gives us the total value ng ganyan. And if you do error, equal lang to sa ito minus sum nung nasa taas. Okay? So I can just drag this down. No? And ito, pwedeng i-copy ko na lang to. Yan. Same lang naman siya. Tapos ito, this is just equal to count ng total number of replicates minus 1. Okay? So I should get this value. So if you compute for MS, ito over this one, That's my MS value. Fcalc is equal to this one over MSE, which is the error. F4 natin para ma-fix. So, pwede natin i-drag down papunta dito. P-value is just f.this.rt. And we're looking for this value, degrees of freedom 1, denominator, degrees of freedom 2. Again, F4 tayo para ma-fix. Then we can drag it down and pwede delete ito, no? Tapos, since marami to, we can use the if na technique, no? So, if p-value is less than 0.5, then we say significant. If not, then we say not significant. So, ito, mas mabilis class, no? So, kaya dito na yung value ng pag doing if function, no? Kasi di na kailangan mano-mano nyo siyang i-compute. So, yun. Automatic na. Lalo na pagka marami, no? Something like this. Sobrang daming factors. 4 factors. Sobrang daming kailangan i-compute, no? So, ito, we can take advantage of yung automation na ginagawa ng Excel. Okay? So, yun lang siguro for today and you can make the final conclusions no kung ano yung factors that are significant. All main factors are significant. The two-way interaction of AD and AD, BC. Parang doble yung AD. Ay, nadoble ko yung AD. Anyway, i-double check ko to before ko i-send sa inyong class, no? Martin asks, needed po ba ang FCALC if gumamit ng p-value? Yes, kasi hindi mo makukuha yung p-value without the FCALC, no? Yung FCALC, p-value kasi nanggagaling sa FCALC. Okay, so yun. May mali lang siguro yung bakit na doble tong AD. So hindi ko alam kung bakit na doble yung AD. Mukhang dahil dito, no? Nagkamali ata ako dito. AC. Ano yung kulang ko dito? AC, AB, AC, AD, BC, BD. Dapat ito may kulang, no? CD ata. Tama ba? CD yung wala. Okay, kaya pala. CD. Since dynamic to class, pwede namang magbabago naman siya diretso, no? So, yun. Tapos nagbago na lahat. Okay? So, ayun. Thank you, Russell. Yun lang. Thank you for coming in today. Tapos, I'll meet you next week. Tapos, hindi next week. Next week kasi reading break pa yung 5. Tama ba? 29 to 5 kasi ang reading break. So, baka mag-meet tayo on Friday na lang. 7. Ganun na lang. Okay? Tapos, before we end, no? May questions ba kayo dito sa Yates technique tsaka table of signs? Medyo confusing lang siya pagka maraming values, no? Yung Yates technique lalo na kasi parang kailangan sakto yung nyo, yung pag-add. Pero if I can find the parang algorithm na na-develop ko dati para mas accurate siya, I'll share it with you guys, no? Pero right now, pwede namang manual nyo siyang i-add, no? Tapos, Martin, saan types of problem po ito appropriate na gamitin? Sa mga variable screening problems. Like, for example, meron ka multiple factors, 2 levels each. Nagva-variable screening ka, gusto mo ma-determine if which factors affect which response variables. Then you can use 2 to the K design. Yes, nagpag-usapan namin ni Martin to kanina, no? Yung RRL method, and I'll make an separate announcement dito, no? Pwede natin i-move na lang yung date kasi may ilan sa inyo medyo confused pa, no? Pero I highly encourage na mag kayo, no? Magpa-consult kayo. So some already have consulted. I-reply ko na lang through email. Or you can use yung bit.ly link natin, no? Para hindi tayo lito yung Ask Sir Stan. Ay, sorry. Mali yung everyone dapat. Eto. Okay. So, okay tayo. I'll send this spreadsheet para pwede nyo i-analyze on your own. Tapos tingnan nyo kung paano nyo siya i-manipulate. Tapos, if you can develop your own algorithm, para ma-use yung Yates technique is better, no? And if you want to share it with your classmates, pwede naman i-share nyo through the forums, no? Okay, so thank you for coming in today, and I'll see you next week. And enjoy your reading break, no? Okay, thank you.